In this video, we will go over the difference between a hydride shift and a proton transfer. A hydride shift happens when there is a carbocation that could be more stable, and a hydrogen will move with its electrons, allowing the carbocation to move to a more stable position. A proton transfer is one molecule stealing hydrogen from another molecule, but leaving its electrons. Anytime you form a carbocation, you look at the carbon that is positive, and you check how substituted it is with other carbons. We see that there are 1, 2 carbons around it, so it is secondary. We will then look at each of its surrounding carbons, 2 in this case, to see if any of them would be a more stable carbon for the positive to be on. We would be looking for more substitution, tertiary in this case, or even better would be an allylic or benzylic carbon. Allylic carbons are carbons that are 1 carbon away from a double bond. Benzylic carbons are 1 carbon away from a benzene ring. If we start with the carbon on the left, we see that it is only attached to one other carbon. It is primary. The other carbon is attached to 1, 2, 3 carbons. It is tertiary, and therefore would make a more stable carbocation than the secondary carbon. We know that there is a hydrogen here. The electrons of this hydrogen are drawn to the positive charge on the secondary carbon. They will therefore attack the carbon, and the hydrogen will move to the secondary carbon, leaving the tertiary carbon without a fourth bond, which makes it positive, becoming the new carbocation. The secondary carbon, which only had 1 hydrogen when it was positive, now has another hydrogen and is happy with its 4 bonds. Returning to the difference between a hydride shift and a proton transfer, now that we understand what happens in a hydride shift, let's talk about the vocabulary. A hydride is a hydrogen with 2 electrons, meaning the hydrogen and its bond. A proton refers to a hydrogen without any electrons, and as a hydrogen atom has no neutrons, without any electrons, it is simply just a proton. A proton transfer is a result of differing pKa's, or in other words, an acid-base reaction. For example, the pKa of a carboxylic acid is around 3 to 5. If we look at this oxide on the left with a proton, we see that protonated it would be an alcohol. The protons of alcohols have a pKa of around 16 to 19. A pKa that is larger than another will act as a better base, meaning that if it is without that proton, it will take a proton from another molecule with a lower pKa. A lower pKa makes a better acid, meaning it is better at giving away a proton. Consider it as a ranking of who is better at taking a proton. The proton always goes to the higher number and is lost to the molecule with the lower pKa. The mechanism is that a lone pair from the higher pKa molecule, the oxygen on the oxide in this case, will reach out and attack the proton with the lower pKa. The bond to that hydrogen will break and return as a lone pair onto the other oxygen, leaving it more negative. If this video helped and you'd like to give back to a free tutor, please like and subscribe, and let me know in the comments if there's anything you would like to see in future videos, anything that you have problems with in organic chemistry or general chemistry. See you in the next video.